Good evening, I'm A152. For this project, we decided to perform FEA analysis on the front upright and the hubs of the current UCI FSA race car.
The upright is a component of the automotive suspension, which houses the hub, which is affixed to the rim and tire. The upright and hub are pictured here in blue, the rim outlining in gray, and the brake, disc, and caliper in gray in the center. The upright has two main functions, the first of which is to be an interface for which the hub and the rim and tire can be affixed to. All of the resultant forces on the suspension of the car begin with the tires. The tire and wheel assembly are affixed to the hub, and the hub's only connections are in the upright. This means that all the forces acting on the wheel must pass through the hub and into the upright. The second function is to act as an interface to the front suspension. All forces transmitted into the upright by the tire are directed into the chassis through the upper and lower suspension tabs. These include spring compression in corners and in braking.
In the bump scenario, there's a 600-pound force occurring at the contact patch for both the upright and the hub. We simulate this by utilizing remote loadings.
Our forces due to a bump scenario include an off-center upwards force on the upright where the hub is sleeved into it. The upright is fixed from the upper and lower suspension tabs and exhibits reaction forces in these locations. On the hub, a bump scenario involves an upwards force on each of the three lug bolt holes. A reaction force is exhibited by the far section of the shaft where the hub sleeves into the upright.
In the brake scenario, there is a 176 pound-feet torque applied to the brake rotors, 341 pounds in the y direction since the weight of the vehicle shifts forward, and 515 pounds in the negative x direction, which is the force of friction when the tires are not allowed to spin.
In a maximum braking scenario, torque is applied on the brake caliper tabs of the upright, and reaction forces are seen in the upper and lower suspension tabs. On the hub, the torque is applied on the center section of the shaft, and reaction forces come from the lug bolt holes.
In the bump scenarios of the upright, we utilized remote loadings. For the first iteration of the upright, we saw there was a factor of safety of 18.4, far surpassing the minimum 1.2 factor of safety FSA normally strives for. Having a high factor of safety shows the upright is overbuilt and utilizing more material than necessary. Under the braking scenario, the upright had a factor of safety of 1, which is far too low for our requirements. The maximum concentrations for stress occur at the top left of the middle bracing member. On the second iteration of the upright, we were able to increase the factor of safety by increasing the wall thicknesses, while decreasing the weight by removing the bracing members. The first and second iteration of the hub both performed well in the bump scenario. This was expected since the only real difference is in the brake rotor mounts. The brake scenario is where the two iterations truly deviate from each other. With such a large torque on the brake rotor mounts, the first one failed with a factor of safety of 0.29. By creating a circular profile around the rotor mounts, we were able to remedy this problem.
Modal analysis performed on the hub and upright to understand the resonant frequency when going over bumps. The same boundary conditions were used in the frequency study as the static study for the bump scenario. Different shape deformations were obtained for the 5 modes. A fatigue study was performed on the upright and hub because the minimal life cycle of the brake scenario has a far shorter life expectancy than the bump scenarios. From this study, it can be seen that the upright has a minimum life cycle of 1,265 and the hub has a minimum life cycle of 7,000. The effects of maximum braking is more severe than bump force, which is due to the large torque on the fragile parts of both the upright and the hub. This concludes our 152 final project. Thank you.